Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just resolved on my own after a year. So I'm really happy that I was able to come up with my own solution to this question without any assistance after a year. So let me show you how I did it. This one is called Sum of Even Numbers Up to Queries 985. Basically the question is pretty simple. Change this index to this value and then at each turn sum the total how many even values times the even values themselves. So sum all the even values. So a naive approach would just be to go over each query and reflect that change. So let's call this index and value is q of 1, q of 0. It's like backwards here, but that's fine. And then we're just going to say the value, which is this value. So let's say current value is c of nums of index. And then if the current value, we're just going to say, so we want to get rid of, we want to add something to it. So basically get rid of that original value. So c nums of index minus equal to 1. If c of nums of index is equal to 0, then we delete it because there are no frequencies left. And then c of, we're just going to say c of nums, well, nums of index plus equals to the value, and then c of nums of index plus equals to 1. Okay, and then we need an array, and then we can just go over this dictionary. If this is an even number, then we just add it to the current total. So keys are unique, so the number times how many times it appears in the whole array, and then append total, and then return the result at the end, right? So this technically works, but this is n squared because it's a bit slow. So there's a way to optimize this that I came up with, and I'll show you. So time limit exceeded. Basically, let's first just get this counter, and then let's keep track of the total here. Let's get only the even numbers, right? Because that's all that we care about. So if a is even, then plus equals to a times b, the number times how many times it appears. And then when we do this change, instead of doing this, c of nums of index minus equal to 1. So first of all, if nums of index is an even number, then we can subtract 1 time because we're changing that value, right? So we're removing 1 and then adding 2. So the difference is 1, right? And then here, if the new value after we changed it, nums of index is even, then we can add the new value, right? We only care about the even ones, and that's the key point here. So let's run this and submit it. And there you go, passes all test cases. So again, I'm super glad that I was able to solve this one completely on my own without any help. And the time complexity is now O of 2 times n instead of n squared. Right? No double loops. So we're just looping 1 time and then another time. So yeah, that's it for this video, and thank you for watching.